So this is problem numbers 18 through 24. They kind of all go together. So I drew the figure in the book, and it's right over here at the upper right corner. So the first question, though, doesn't ask us to look at the whole triangle. It asks us to look at ABC. So I went over here and I drew ABC. If they're telling you to just look at part of an information on a diagram, notice it's kind of helpful to separate it out, because what they're using here, doesn't this look like the law of sines that they're using here? They got the sine of an angle over the side opposite. If you look here, the sine of angle 1, and then what's the side opposite? It's y, isn't it? So isn't that how they made this little fraction here? Just remember, it's the sine of the angle over the side opposite it. So they labeled that y. So if I want to, they've got a question mark there they want me to answer. So if they say that's equal to the sine of angle 4, we're going to put that on top, and on the bottom we put the side opposite it. So what's the side opposite angle 4? It's just x, right? So the law of sines is always kind of, most people prefer it because it's just a lot easier. You don't have to, you're looking at an angle and a side opposite, and you just got to find two pairs of those to use in your formula, and you always kind of, if you were solving for a value, you'd want to make sure you picked the thing you're looking for, and then another set of the information where you had both sets of the angle and the side opposite of it filled in. So if you look at number 19, now they're talking about ADC. So they're talking about, let me highlight that on maybe with yellow. That would be this here, this yellow triangle that I'm kind of highlighting here. I don't know if you can see that or not, so let me pick a different color. I'll use like a green or something. So if they're looking at the sine of angle 4, this is angle 4 right here. In that triangle, what's the side opposite angle 4? X, and they actually filled that in for us. So what's the side opposite angle 3? Y. So that one's going to be Y. So they're actually hoping you'll notice something here. Here's sine. Look at what's in common between 18 and 19. Don't both of them have sine of angle 4 over X? So you got Y on the fractions that they're equal to. Don't they both have Y on the bottom? So what does that tell you about sine angle 1 and sine angle 3? They have to be equal. Yeah, they have to be equal, don't they? Because if you got the same thing on the bottom, then the tops of those fractions also have to be the same thing. So if you were to look at those two fractions, they've got to be equal. Sine angle 1, that means the numerators have to also be equal. Sine angle 1 is sine angle 3. That's kind of like the substitution property or the transitive property if you think about it. These two purple circles are the same thing, so these other two things have to be equal, and since the bottoms are both Y, then the tops have to be equal also. So that's all they're asking you to notice there. Okay, and then on number 21, it says if angle 1 is 72, find angle 3. Well, we don't need any trig for this, if you think about it. Why don't I need trig for this? What did you do to find angle 3? I marked something on that figure originally in red that I'm not sure if you can still see all of it.
Oh, it's supplementary angle 2.
Yeah, it'll be supplementary angle 2. How do I know what angle 2 is?
It's congruent to angle B.
Or, yeah, right, and they've labeled that angle 1. So, yeah, we kind of got to, they told me angle 1 was 72. So this is 72. This x and this x means we've got a little isosceles triangle in there. So if angle 1 is 72, angle 2 is 72, and then 3 and 2 are supplementary. So I could find angle 3 by saying that's 180 minus 72. What's that, 108? Is that what y'all got? If I'm not subtracting incorrectly. Okay, so 108 there. Okay. Oops. I don't know whose it is, but if you can shut it where it doesn't make a sound, maybe that'd be good. So if sine angle, what would sine angle 1 be? It would be equal to what? And why do you think that? Where'd you get that from? You're right.
Well, because at the very beginning, look at the two, like on number 18 and number 19. The sine of angle 1 over y sine of angle 3 is over y.
Uh-huh.
So that equals
Uh-huh.
both the same.
And like, and you look at here, and that's what we said, sine angle 1 is equal to sine angle 3 right here. So we know that angle 3 is this 108, so sine of angle 1 would be equal to the sine of angle.
So the sine of 108 is equal to the sine of...
Yep.
Oh, that's what they're wanting you to know?
Mm-hmm. They're wanting you to see that the sines of supplementary angles are the same thing. Okay. Sine of angle 3. Actually, we could actually go find that number because we know it's 72. So let's just put in sine 72. I'm not sure. Sometimes I'm not sure exactly. Like, are they meaning for us to actually punch it in the calculator there or notice a relationship?
That's what I did, but it's easier than that.
Yeah, let's go ahead and put it in the calculator also. Let's just mark that out. We'll see this in a second. Sine of 72 degrees is 0.9511 if we round it, right? And then angle 3, we found out it was 108. So what's the sine of 108?
Oh, it's 911.
Yeah, same thing, isn't it? So the sines of supplementary angles are equal, congruent, whatever you want to say there. I'll just put equal since they're equal values. I'll just put equal here. Okay, so 34 wants us to write the equation for a squared in terms of b and c and cosine a. Here's the deal with the formula. If I'm trying to find the side A, it ends up looking like the Pythagorean theorem. You take the other two sides and square them, if you remember from yesterday, and then you subtract 2 times those two sides, and then it's the times also the cosine of the angle across from the thing that's sitting over here by itself, so it's going to be the cosine of A since A squared's over there. So that would be the formula. You always, whatever side you're solving for, it goes on one side. You square the other two sides and add them together.
Oh,
Subtract 2 times those two sides, and then the cosine of the angle across from this thing that's by itself. Okay? And they kind of presented the information a little differently than most books do, so I can see where it would be a little confusing. It says solve for A and B and C. Oh no, substitute A for B and C and solve the equation for cosine A.
So 34 is just the equation?
Yeah, that's the equation is all you're doing. And let's see, the equation that they gave you in the book, they put it in terms of c squared.
Oh.
So they're kind of having you write, most books give you like, it's solved for a squared, and it's solved for b squared, and it's solved for c squared. They only gave it to you solved for c squared, and they're just figuring that you're going to see the pattern, and you can write number 34 just like this. And we kind of talked about the pattern yesterday, but I don't know that y'all seen enough of it that it's sticking with you yet. It wouldn't be for me, okay? Just I know for me. Look at 35, then they say substitute A and B, A for B and C. So, and why are they telling me to substitute A for B and C?
Oh, because it's equilateral.
Yeah, it's equilateral. Aren't all the sides the same? So I really don't need to call this C. I can call it A if I want to. And I could also call this A if I want to, right? Because they're all the same. So instead of using 3 different variables, since they're all the same value, let's just pick one and go with it is what they're basically doing here. So on this side I have A squared. Now B is the same thing as A, so we're substituting in A for that one. We're substituting in A for C because it's the same thing. And then again, we're going to substitute A for B because it's equal. Remember, we're just going off the assumption that A and B and C are all equal to each other since it's equilateral. C is also equal to A, so we can put it there. And then we're supposed to solve it for the cosine of A. So they really don't want us to plug in 60 here, even though we know that's what it is, okay? So let's see what happens with all the algebra here. I get A squared on this side. How many A squareds do I have on the right side? 2A squared minus 2A squared cosine of A, right? Okay, so they want to get cosine A by itself, okay? So what I'm going to do is I'm going to circle cosine A. They want me to solve for cosine A by itself. I know that's 60 degrees, but they're not just saying plug, they're just want me to kind of move these terms around and see what it looks like. So if I want to get cosine A by itself, The first thing I need to do is add or subtract anything I can. So can't I subtract 2a squared from both sides?
But isn't 2a squared minus 2a squared?
Oh, but it's not minus 2a squared because this is multiplied by cosine a, so I got to split it apart a little differently, right? If you think about a little bit about algebra, yeah, you got to have to split that apart. It's okay. No, that's okay. That's a good question. On the left-hand side, a squared minus 2a squared would be negative a squared, And over here I got negative 2a squared times the cosine of a. And they want me to get the cosine of a by itself.
Divide by negative.
Yeah, I'm going to divide by negative 2a squared. Let me get that negative to show up. Okay, so those cancel out, and I get cosine of a is 1/2, right? Because I can put an invisible 1 in front of that a squared. A negative over a negative is a positive. The a squareds would cancel out, and I'd end up with 1/2. Now, the cosine of what angle is 1/2? We have to go back to our 30, 60, 90s, just like we did on the quiz today. Across from the 30, I label it, we'll use x's here since we don't have any x's in this equation. Across from 60, that's x squared to 3, right? And across from the 90, that's 2x. I knew that I needed this because I'm trying to figure out how am I going to get 1/2 out of this, and I know I can get a fraction here of 1/2 because look at, we kind of know it's 60 degrees, don't we? So that was a clue to me to draw the 30, 60, 90. We already knew it was really 60 degrees, so that's kind of one reason I knew how to do this, plus I'm doing a lot of trig right now in trig, so that's another reason I need to do it. But if I look at 60, here it is. SOHCAHTOA says that the cosine is the adjacent side over the hypotenuse, right? Because that's C-A-H. So the adjacent side, let me label it also that way because we actually have two different kinds of labelings we can do. Across from the 60, this is the opposite side. Across from the 30, this is the, I'm sorry, I'm labeling just from the 60. I'm sorry, brain is dead. Across from the 60, that's the opposite side. The next easiest side to label is always the hypotenuse because it's always in the same spot. So this must be the adjacent side. I want to make a fraction with the adjacent side on top, so that's x. And I want to put the hypotenuse on the bottom, that's 2x. Let me fill in with an invisible 1 here because I've seen that mess people up on quizzes today. And when I cross the x's out, I'm left with 1/2. I just took the cosine of 60 and saw that it was 1/2. So isn't my angle A 60 degrees? And that's really what it should have been, right? Because it was a equilateral triangle, it was 60, 60, 60. So we just found out that angle A is 60 degrees, and we could have even used our calculators there. In trig, this is what you do, though. You go draw these, special triangles here that we've already talked about this year. Oh, okay, so we could have put that in the calculator and done inverse cosine, which is second cosine, and entered in 1/2, and we would have seen that was 60 degrees. If you look at the next one, they actually axis. Oh my gosh, been watching too much. Never mind. On 36, they tell us to draw a 30, 60, 90 triangle. And so, that's kind of what I thought to do in the first place because that's what we do in trig. But they actually kind of tell you, go draw it and notice that the cosine of 60 is 1/2. We knew it was 60 because it was equilateral. I could have put it in the calculator and got 60 degrees. And now, if I draw this triangle, I see it's 60 degrees. I got like 3 ways to see that this is 60 degrees. So that's what they were trying to get us to do there.